Welcome back again, guys. Thank you so much for checking out these videos, and I hope they help a little bit. What I wanted to do today was I wanted to talk about rotation. I know rotation has been an issue for some of us, so this video will maybe help us figure out rotation a little bit better. This here is a Cartesian plane. A Cartesian plane is an x and a y axis that intersect at the origin. So this point right here is called the origin because that's where the two intersect. If we were to plot that point would be 0, 0, because it's 0 on the x-axis and 0 on the y-axis. Where I want to start today is to label the x and the y-axis using positive and negative integers. In grade 6, you would have done labeling with coordinates using an x and y axis, but it would have dealt mainly in this area here, okay? In grade 7, we're going to use both this area, but we're going to use the other quadrants as well. The way we label it is anything that goes to the right or goes up is a positive number. So let's write in some of those numbers. Let's write some of those in. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I think that's enough for now, but we could keep going till infinity. Your hand might get a little tired by then. You'll notice that I put each of the numbers on the line so that when I follow the line up, I know where to plot my point. I'm going to do the same thing on the x, that was the x-axis. I'm going to do the same thing on the y-axis. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. We'll stop there. But now when I go down or to the left, if this point here, the origin, is 0, anything below 0 is going to be a negative number. So we have -1, -2, -3, -4, 5, -6, -7, -8, -9, -10, and I'll stop there. And if I go to the left, because the right was a positive, the left has to be a negative. So we have -1, -2, -3, -4, and so on. Let's review the instructions. The first thing says to plot points A, B, and C. Point A is located at 7 on the x-axis, right here, and 1 on the y-axis. So if I go over to my x-axis, I am going to count to 7. 1, 2, 3, 4, 5, 6, 7, which is right here, and 1 on the y-axis, which is here, and I make my dot. Going to go and erase the initial dot I made. Perfect. And I have 7, 1 plotted, and I'm going to label it A. Now I'm going to go to 7 on the x-axis again, but I'm going to go to -1 on the y-axis, which would be right here, because if you follow it to the left, you'll see it gets to -1. And finally, C is at 9 and 0. So 9 on the x-axis and 0 on the y-axis. So that's C, and that is B. And when I connect those dots, I have a triangle. So 3 vertices means 3 lines, which means a triangle. Next, it wants me to plot a rotation point. Now my rotation point is at 4 on the x-axis and 1 on the y-axis. So 4 on the x-axis and 1 on the y-axis is right here. And that's my rotation point. As we talked about in class, the best thing to do when you have a rotation point is to set up a vertical and horizontal line to make it easier to know where you're rotating to. Now you might be using a ruler so your lines are a little straighter, but the nice thing with working with a grid is that the lines are already there for you. If we look to the left again, we can see that the instructions now tell us to rotate our shape 90 degrees counterclockwise. So we're going to rotate the shape, but the vertices or the points are a part of that shape. sometimes it's easier to actually just take each point, rotate it 90 degrees, or whatever the instructions say, and then connect the lines again. That's what we're going to do in this situation. I want you to look at A. We're going to go 90 degrees counterclockwise. We know that clockwise goes around like this, and counterclockwise goes the opposite. It goes around like this. So if I want to move this shape, which is in this quadrant, counterclockwise, it's now going to go into this quadrant. Whenever we do any sort of rotation, our rotations are in 90 degree increments. If I'm starting with this line and I'm moving over to this line, it's going to be 90 degrees. If I go to the next line, it's going to be 90 plus 90, which is 180 degrees. And if I go to the next line, that's 270 degrees. Knowing that I'm going to be going over here 90 degrees, I'm going to take A, which is here, and I'm going to move it to the next line 90 degrees counterclockwise. The point will always be the exact same distance from the origin of the rotation point. Currently, we have it at 1, 2, 3 away. So I'm going to move it 3 away from the rotation point on my 90 degree counterclockwise line. So 1, 2, 3, and that is going to be my point. Now instead of calling it A, because that could be confusing, I'm going to call it A1. Next, I'm going to move B. When I move B, I know that B is going to be 1, 2 away from my new line, and it's going to be the same distance from the rotation point. So 1, 2, so I put my point here. And finally, C is going to be 1, 2 up and 1 over from A. 1, 2 up, 1 over, and then I connect my dots. And I label them. So this was B1, and this is C1. So that is a 90 degree counterclockwise rotation. If I was to rotate it 180 degrees, I would do the exact same thing. I'd take it from my A point to 90 and over to 180. And it would be 3 away from the rotation point, right here, along that horizontal line. And we'd have our B2, A2, and C2. I just connect my lines. So that would be a 180 degree rotation. And the same for a 270 degree rotation. I'm going to now move it over into this line. And A is going to be along the line, 3 away from the rotation point. 1, 2, 3. So I've got that point. And we have our B3, which is going to be 2 away. And C3 is 2 up and 1 away from A. So this was A3, B3, and C3. I hope that helps a little bit. We had a 90 degree counterclockwise, we had a 180 degree counterclockwise, and a 270 degree counterclockwise. And if we continue over in this direction, we get back to where we started, which is a 360 degree rotation. Thanks, guys.